we challenge the limits of the impossible.
In our last video that I leave you in the description in case you missed it, we explore how the quantum chip is destined to change the world. We know that quantum chips like Google's Sycamore and IBM's Eagle are marking historic milestones in quantum computing. But many wonder when we will be able to see them in action in our daily lives. Although these technologies are still in experimental phases, practical services based on quantum computing are expected to start appearing in specific sectors, such as energy optimization and artificial intelligence within 5 to 10 years, for example. IBM plans to launch its Condor chip with more than 1,000 qubits in 2025, a key step towards commercialization. However, the true quantum revolution, with massive and accessible applications, could arrive between 2032 and 1040, when chips like Google's future processors with millions of qubits manage to overcome current challenges of error correction and scalability. Does this mean that we are closer than it seems? But there is still a way to go before this disruptive technology completely transforms sectors such as energy, medicine and security, the electric car, solution of the present or a transition. Electric cars are the symbol of the current energy transition, with governments encouraging their adoption. It seems that we already have the answer to sustainable mobility, but what is it really like? Although promising, electric cars have important challenges. Its batteries rely on scarce materials, such as lithium and cobalt, whose extraction has a significant environmental impact. In addition, prices remain high, and their production requires large amounts of energy. This is where quantum computers can help by simulating millions of scenarios. They could optimize the design of cheaper and more efficient batteries, as well as improve power grids to support future demand. Green hydrogen. A clean fuel with several challenges. Green hydrogen is another of the great promises of clean energy. This fuel, which only emits water as waste, can be used in transport, industry, and electricity generation. But its current production faces significant challenges. Producing green hydrogen requires huge amounts of renewable electricity, which generates an environmental impact due to the necessary facilities such as wind and solar farms. But with the help of quantum chips, we could simulate more efficient chemical processes and design electrolyzers that reduce these costs. Nuclear fusion, the energy of stars. Nuclear fusion could be the ultimate solution. This process, which occurs naturally in the sun, could provide unlimited clean energy without radioactive waste. But stabilizing a fusion reaction is one of the greatest scientific challenges. Quantum computers are essential here, simulating the perfect conditions to stabilize these reactions. Projects like ITER. Are they already using these technologies to advance towards energy from the stars, energy from space harvesting the power of the sun? And what if we could capture energy directly from space? Solar satellites could collect sunlight in orbit, where it is constant and more intense, and send it back to Earth using microwaves or lasers. Optimizing the design of these global energy networks is another major challenge, where quantum chips can make a difference by simulating millions of variables to ensure anti-gravity efficiency and sustainability. The most disruptive idea, anti-gravity, is one of the most futuristic and theoretical ideas, but also one of the most fascinating. Systems based on gravitational forces could generate energy or move vehicles without fuel. Knowing the enigmas that this type of energy raises is as much as knowing how ships from other worlds that visit us are supported in anti-gravity, and that this humble author witnessed as a witness of one of the most incredible UFO sightings was one of those amazing space vehicles. Or rather, a huge extraterrestrial ship whose story we will tell in the next channel video. Although we are far from fully understanding these forces, quantum chips could be the key to modeling their behavior and designing functional prototypes of spacecraft or vehicles that defy Earth's gravity, dark matter energy, and quantum vacuum. Beyond hydrogen, nuclear fusion, or solar energy, scientists are exploring much more exotic and revolutionary energy sources. One of them is the energy contained in dark matter and the quantum vacuum, concepts that seem taken from science fiction, but that have theoretical bases in quantum physics. Quantum vacuum, for example, is not really empty. It's a field full of particle and energy fluctuations, known as zero-point energy. It is estimated that a single cubic centimeter of this vacuum contains more energy than all the electricity generated in the world today. How can quantum computers like Sycamore Eagle take advantage of it? They might simulate these processes to tap into this incredible energy source. Though we're in early stages, this research could revolutionize from powering spacecraft to replacing all known energy forms. Link to space exploration. The energy future isn't just Earthbound. With projects like NASA's Artemis or the missions to Mars, the challenge is to find sustainable energy sources in space. This is where technologies like solar satellites and nuclear fusion in space come into play. For example, solar satellites in orbit could constantly collect energy and transfer it to stations on Earth using microwaves or lasers. In addition, quantum computing could design complex simulations to optimize the position and efficiency of these satellites, making them take full advantage of solar radiation. And on planets like Mars, where conditions are extreme, compact fusion reactors designed with quantum simulations could be the key to establishing self-sufficient human colonies. Imagine a world where the energy that powers our homes here on Earth is designed and perfected in the energy biomimicry space. Nature as inspiration. Quantum computing can not only help us explore new forms of energy, but also learn from nature. An example is energy biomimicry, where natural processes are simulated to generate clean and sustainable energy. For example, scientists are investigating how plant leaves convert sunlight into energy through photosynthesis. With quantum simulations, we could design materials capable of replicating this process to create next-generation solar panels, much more efficient than current ones. Another case? It's how some marine organisms harness underwater currents to generate energy. With the help of quantum computing, we could create devices that simulate these processes and capture energy directly from the movement of water or wind inspired by life itself. A quantum global energy system. Imagine a world where all energy sources are interconnected. In a global system managed in real time by quantum computers. There would be no losses, blackouts, or waste. Every home, vehicle, and device would be part of a smart ecosystem that optimizes energy use to ensure sustainability and abundance for all. Final reflection, the future of energy. It is not just a promise, it is a challenge in which innovation, science, and our ability to learn from nature and the universe converge. From quantum vacuum and space energy to nuclear fusion, anti-gravity energy, and advances in biomimicry, the possibilities are as endless as our imagination. And at the heart of this energy revolution are quantum chips like Google's Sycamore or IBM's Eagle, which are already shaping a wonderful world where these advanced technologies can not only exist, but also thrive. Imagine a future planet where every home, every vehicle, and every city are interconnected by a smart, clean, and highly efficient global energy system. These systems are designed and managed by quantum computing. However, the journey ahead is not easy, and the coming years will be crucial in determining how these concepts will become reality. What is your opinion? Will the quantum chip be the powerhouse of the future, or will we witness the emergence of other astonishing technologies? If you wish to continue delving into these thrilling topics and stay apprised of the technological advancements that are revolutionizing the world. Subscribe to Technology, join our thriving community, and accompany us on this captivating expedition into the future. Click like, share this enlightening video, and leave us your valuable comments. We are eager to learn what inspires you about the future we are collaboratively building, your thoughts, and the questions you may have.
Break the chains of shadows lost, rise above the tempest cost. Our hearts, they blaze with fire untamed. In freedom's name we are proclaimed. Through valleys deep and mountains high, beneath the